Good morning, everyone. Welcome to the latest of our Tech Tuesday webinars. We're just going to give people another minute or so just to start their computer and log in. For those of you attending, welcome. Thank you very much. We will be recording this webinar so that it will be published later on for anybody to look at again or share with your colleagues. And we will also have the ability to take some questions. There is a button, a Q&A button that will allow you to ask questions as you go along. We will have time at the end to answer questions should you have them. Alternatively, please, by all means, after the event, talk to your account manager and ask them any questions that you come up with during the presentation. So I think we are probably at that point. So welcome, everybody. Thank you for joining us on the latest of our Tech Tuesday webinars. I'm just going to share my screen and show you what we're going to be talking about today. The subject of today's webinar is combination D connectors. These are very familiar products. D connectors are some of the most popular connectors in the world. But we are talking today about a specific subset, a specific section of the D sub universe, specifically with regards to these combinations, the idea of different pin sizes within the same connector shell. So what we're going to talk about today, we're going to cover an overview, talk about the actual D sub themselves and the design of them. We'll focus then on this combination technology, the fact that we can have different pin sizes in the shell and some of the functions that they serve. We'll talk a little bit about the contact performance because that's critical to how these things work. It's all about what the contact is able to do in terms of current carrying capability, signal speed, things like that. We'll talk about why people should choose and why people continue to use combination D subs in the current connector marketplace. And then we'll talk something about applications and industries that are still using these things widespread. So we'll get straight onto it. D sub connectors are, as I said, some of the most popular and some of the most recognizable connectors within the entire interconnect marketplace. They've been around since the late 50s. They were designed originally to be an alternative to some of the circular and some of the rectangular connectors that were used in the aerospace industry. Customers were looking for things that were smaller and slimmer. And so this connector design was created in the 50s as a real alternative to some of those bulkier connector types. They have subsequently been used in pretty much any industry that you can imagine. They've been to space, they've been under the sea, they've been used in every industrial, commercial, aerospace type application that you can imagine, and they continue to be popular today. And they've evolved. They started out, this is a 9-way D sub, which will be very familiar to many of you. They started out as a simple 2-row connector shell. The D sub shape, the D connector shape there is very obvious, and that's what gives the product the name. The idea that you won't be able to plug the connector in the wrong way round. And we have 2 rows of contacts. These are size 20 contacts, and they are designed, everything being an imperial measurement, they are 1.02 millimeter pin. And this is the product that almost revolutionized the connector industry at the time. But they've evolved. During the time of these connectors, getting on to the late 60s, early 70s, people realized that we need more pins in our connectors. The rise of digital computing and the number of extra signals that need to go through these things meant that people were looking for an alternative. And so the high density D sub was invented, exactly the same shell, but using smaller pins that were packed closer together. So in this case, the 9-way shell all of a sudden has 15 contacts in it. And throughout the whole range, the same increase in pin count can be seen. So the 15-way D sub, for example, has 26 pins in its high density variant. So the idea is that we are having an increase in density, an increase in number of pins, and a more capable connector. And these two have been very, very popular. In fact, if you are as old as I am and you can remember computers before the days that USB took over everything, This is something that will be very familiar to you. The rear of any computer would be awash with D subs. We've got serial ports, we've got parallel ports, we've got the 15-way VGA, the blue connector in the very center there, the VGA connector that connects your computer to your display. So every computer in the world for a long time had these connectors built into them. It's one of the reasons why they are so popular and so familiar. But they've also evolved when people realized that we need power and as well as signal into some of these devices. And that's where the combination D comes in. So again, we have exactly the same shell size. This is a 9-way D shell, but we've got a different pin arrangement. We've got a combination of the standard signal pins with the large size 8 power pins. And there is an enormous variation across the range of D sub shells that allow this combination of different pins. And as a result, they have been used in almost every industry that you can imagine. As I said, these things have been to space. They can be seen in the smart farm. They can be seen in the data center. They can be seen on the factory floor. The combination D sub is still a very relevant, very useful tool for the electronics design engineer. And so that's what we want to talk about today. So the first thing to talk about is how we classify the contact arrangement of these connectors. This shell is slightly larger than the one we were looking at. This is a 15-way D shell. And if this was a conventional D connector with just the 15 pins, then we could quite happily talk about a 15-way D shell, and we'd be exactly aware of what we were talking about. But here we've got a slight complication. We've got two different sizes of pins and different counts. So something that will be familiar for many of you is the way that we classify these. We talk about, in this case, a 7W2. You think about that as a 7 with 2. We have 7 contacts, and 2 of them are these large pin sizes. So 7W2 is the way that we would refer to this particular connector style. And that is common throughout the whole of the combination D range. You'll see many of the options here, starting at the conventional 9-way D shell at the top, going down through 15 and 25, and then if we go down to the 37 and the larger, the 50-way, which are actually slightly thicker. You can see the arrangements are all classified with this same number with number arrangement, so that we are very familiar with exactly what we're getting when we talk about a D sub. And so let's take, for example, this 8W8. This is unique to this connector type shell. If we talk about an 8W8, it automatically will tell us that we are looking at what is a standard conventional 37-way D shell with 8 pins in. You'll notice there is no 8W8 for any of the other sizes. It is a unique classification. So it's like a shorthand for combination D subs. It makes it very easy to understand the product we're looking at. And let's look at the contact performance, because this is at the heart of what these combination D subs do. But we talk about machined versus stamped and formed manufacturing techniques. Now, this is common to all D subs, not just combos. There are 2 standard manufacturing techniques for any pin that goes into a connector. The first is stamped and formed, and the idea is that this is a flat sheet of metal that is then stamped into a shape and formed into a 3-dimensional barrel that gives you this round shape. And if you look closely at the picture here, you'll see a hole and a seam along one side of the contact. And in fact, if you have a connector in your hand and you look closely at the front of the male pin, that will show you whether the connector you've got is a stamped and formed or a machined type. The stamped and formed connector will have a seam. It will be a split where the 2 edges of the metal have been rolled together to form this 3-dimensional shape. The machined contact, by contrast, is actually created from a solid brass barrel. And so it's then milled down into the shape. There are no seams. So it should be obvious with a little bit of inspection whether a connector has a stamped and formed or a machined contact. Now, the next question is, why do we go to the effort of having these 2 different manufacturing techniques? The first is that stamped and formed is much cheaper. A stamped and formed connector can be made in vast quantities in a continual process. and so is much cheaper to make than a machined contact. But there are some penalties to pay for that. If we look at the design of the contact, if we've actually sliced through the middle of it and looking straight down the front, the stamped and formed contact is hollow. That's a function of how it's made. The flat sheet has been formed into a three-dimensional shape, but it's got lots of lovely fresh air in the middle, and fresh air does not conduct electricity. So when it comes to carrying any kind of power, then we need a larger cross-sectional area to keep the resistance to a minimum. And you can see from the picture here that the stamped and formed versus the machined contact has less cross-sectional area. It can carry less current, and it has a lower current rating as a result. There's also a reliability issue. Machine contact is designed from its solid brass barrel, so it will last longer simply because of the way that they work when they're plugged in and out. They are more resilient to repeated cycles. And so that's when we talk about reliability as a key issue. And it should be no surprise that things like military and aerospace connectors almost exclusively use machined contacts, partly because of the current rating, but partly because of that reliability issue. And if we took a look, that gives an idea of the difference in performance. We use mating cycles to denote how long a connector will last. A mating cycle is, as you would imagine, the act of plugging and unplugging a connector once. That is one mating cycle. And it becomes another shorthand, a way of deciding how reliable a connector will be. Stamped and formed contacts, because they're bent from a flat sheet, they're not designed to be so resilient. So a D-sub connector might have only 20 mating cycles, whereas a machine contact could be 50 mating cycles. It could be 500. From last month's Tech Tuesday, when we looked at push-pull connectors, we looked at contacts that are designed to do thousands of mating cycles. They are machined contacts. We can also compare the current carrying capability of these things. The stamped and formed, as I mentioned, it's got this lovely fresh air in the center that doesn't conduct any electricity, so it has a lower contact rating. So stamped and formed contact might be rated at 3 amps, whereas a machined contact with the greater cross-sectional area and the lower contact resistance might be available to provide 5 amps of current. It's not just current though as well. The other thing we have to think about is heat, and we'll get onto that in a moment. But when we talk about a combination D-sub, then we are looking at a very different and much larger contact. These two pictures are in scale. So on the left there, we have a size 22 contact that you will find in a conventional stamped and formed pin D-sub connector. On the right, we have the power contact, the size 8 power contact that you will find in a combination D. And you can see from the amount of yellow in the picture, the cross-sectional area is much, much greater. It gives us a far greater current rating. And in this case, it actually is up to 40 amps per power contact. That's a very big leap from a 3 amp signal contact to a 40 amp power contact, and that gives you an idea of exactly why the combination D-sub is so useful when it comes to connecting both power and signal in a single connector. But I mentioned heat as well. There's another big issue, and heat is a problem that is very much in the news at the moment. Any electrical circuit has resistance. And that resistance will create a loss. It will actually cause some of the energy that's passing through that electrical circuit to be lost as heat. And most connector manufacturers will publish this kind of graph that shows how the temperature is affected by the current that is being passed through that contact. The more current, the greater the temperature. And in fact, it's more serious than that, because if we go back to some high school physics, the loss of power in an electrical signal is the relationship is the square of the current. So if we go from, say, 10 amps up to 20 amps, we're not doubling the heat loss, we're actually quadrupling the heat loss. It's the square. And heat is a big, big problem. So when it comes to connecting things like computers in a data center, where the processor of the computer is generating an awful lot of heat, and is also, with the modern designs, taking a great amount of power to actually provide the computer processing, The power that's needed means that we are pushing more and more current into these cabinets, into these data centers, and with that current goes heat. The advantage of a combination D sub is that you're not trying to spread all that power across tiny little contacts. We've got big power contacts that are designed to do just that. There's also a side effect. The large size of those pins actually works sometimes as a bit of a heat sink. So we are talking about a connector that is far more capable of delivering power, even when the temperature is being pushed up by the current that's going through it. So why would we carry on using combination D sub connectors? It is, after all, a connector that is several decades old, but it continues to be hugely popular in many industries. Well, let's look at some of the reasons why D subs themselves are still very much a standard connector for many industries. They are standard. They are very, very familiar. One of the advantages of having a connector like this that's been used across so many industries is that it's had a number of international standards applied to it. There's ISO, there's DIN, there are some military standards, there's even some spaceflight standards that are applied to D subs, and they cover the actual physical shape and size of the connector, with the idea that a D sub from one manufacturer is actually compatible with a D sub from another. That standard allows it to be something that the engineers can trust, especially nowadays when we've had lots of scares over the last years with things like supply chain reliability, logistics, the collapse of the aerospace, the air delivery industry in 2020. Getting hold of products can be tricky, whereas something that's standard and familiar allows engineers to design with confidence. The features of the D sub itself are still very, very relevant. The shell design, this slimline inline connector, I know we talked about last Tech Tuesday, we talked about circular connectors and the compactness of certain push-pull types. We've got a connector here where you can stack several connectors next to each other because they are slimline and rectangular in shape. And so that shell design makes them very space efficient when we're talking about a computer panel. I mentioned data centers. These are big news nowadays. We are trying to get more and more signals into smaller and smaller spaces. The compact shell design of a D sub makes them very, very relevant. This picture shows very clearly the design of the outside of the shell here. These three little dimples here, these allow a good electrical contact between the male half and the female half of the connector, providing electrical shielding around the connector itself, where we live in an environment that's awash with electromagnetic radiation. Some of it's intentional, some of it's not. And we need to protect the signals that are going through these connectors from interference from that electromagnetic radiation. And the D sub still does that very, very well. It has built-in locking systems, very familiar types that almost everybody who's used a D sub in the past will have seen the screw arrangement that's on either side of the connector. On the female part, the socket that's sitting on the panel here, we've got fixed jack screws, and we've got these rotating screws that will allow you to lock the connector in place, providing physical security in any kind of harsh environment. These are connectors that are going into equipment that can be knocked and shaken. So we need something that's going to prevent them from falling out. The locking systems are a big part of why D subs remain reliable today. And it's not just the locking system that we saw with the jack screws. There are a number of accessories that go with D subs. They allow you to mount on the front of the panel. They allow you to mount on the rear of the panel. There are PCB mounting versions. There are slide locks for quick release devices. Along with the design of the connector have come all of these accessories, all part of the standard. And again, this is one of the reasons why the D sub is so popular, because it's so versatile. There are so many ways of mounting it. There are so many ways of using it. Accessories also stretch to protecting the cable entry. There are any number of choices available for providing cable protection and EMC protection, protection against electromagnetic radiation at the rear of the connector. These are all parts of the D sub family, and many of these can be used with combination D connectors. There is another side of D-sub, which it may surprise some, is that you can actually make D-sub connectors waterproof. They weren't designed originally for this, but with a little bit of clever engineering, then D-subs have been made available with these sealing flanges around the outside of the connector. This allows the connector to provide a panel mounting option that's protected up to IP67, IP68 in some circumstances. And in fact, when we talk about the combinations, I'll come on to the products that the EDAC group have, but we'll talk about the waterproof combo D-subs. They're somewhat rare, and the fact that the EDAC group has a couple of options for combination D connected in a waterproof arrangement is quite a compelling fact. There aren't many people that have that product. So again, it's another one of those reasons why D-subs have remained relevant and still will be for some time to come. The next slide shows how those waterproof connectors can be used in a real world application. We're talking about a panel here. This could be the panel on a computer. This could be a sealed waterproof box. And we're looking for some way to provide an input from outside the box into the electronics within. And in this case, we have a waterproof D-sub that fits to the rear of the panel, is secured in place with jack screws, and provides a waterproof seal around the panel to prevent water getting inside the enclosure, inside the box, and into the sensitive equipment inside. And then we have a waterproof overmolded cable. They can be overmolded, they can be assembled, that will provide a waterproof link from the front here. So a waterproof D-sub connector that is also available in a combination arrangement where you can get both power and signal through that panel. That's a very useful tool. We have another option, slightly different option within the EDAC group. It's difficult to see from the picture, but these are seals within the shell to prevent water ingressing through the shell, which sometimes can be a weakness through past the contacts. So we have an alternative when it comes to waterproofing your D-sub connector. And that is something that isn't necessarily the most common in the industry. So when we talk about the EDAC group of companies and the products that we have, we've got a very broad range of solutions, including at least 2 different ways of making your D-sub waterproof. So we've talked a lot about the technology. We've talked about why D-subs are familiar. We've talked why the combination Ds are so useful because of this allying of power connectors with signal through a single connector. Let's talk a little bit about how these things have been used over the years and why they still are relevant to new industries today. These are some of the traditional homes for D-sub connectors over the years. On the left here, we have a rack and panel type situation within a computer room. D-subs have been used for computing devices for decades, and this is one of the most familiar uses of a D-sub connector. In fact, there are options available with guide pins and float mounts that allow it to be a blind mating connector at the end of this rack and panel situation. So the D-sub, not only is it useful, but it's evolved for use in those computer environments. On the top right there, we have industrial computing. D-subs again have been used for computing in harsh environments. We've talked about the waterproofing. Even if it's not a situation where a connector needs to be waterproof, the vibration resistance provided by some of the locking systems allow connectors to be used in some of these tough industrial environments. And then at the bottom right, we have medical. Medical systems have, again, long used D-subs. The shielding provided by many of these connectors is imperative when you're talking about monitoring patients with very low signal levels from sensors either affixed to the patient or elsewhere. And so a shielded inline compact connector like the D-sub is very useful in that environment. And these very much are some of the traditional homes that you would expect to find D-subs. They are starting to encroach in other areas. Some of them have been used for many decades as well. The top right there, we're talking about battlefield radios and industrial computing that are used in those harsh environments. Again, D-subs being very popular for that world, and D-subs were originally designed for the aerospace industry. So it shouldn't be too much of a surprise that they found themselves into some of those harsh environments. Talking about aerospace, we have here at the bottom right a modern aircraft cockpit, the standard glass cockpit that you see nowadays. If you look at a video of an airplane being flown, the amount of data that's being transferred within the cockpit from computers to displays mean that D-subs are ideal for that application. And indeed, some D-subs were standard connectors for avionics over the years. So these are, again, very traditional, very familiar environments in which you'll find both D-subs and combo Ds. But the picture on the left there is an e-scooter, an e-mobility device, the latest generation of battery-powered vehicles that you see across towns and cities around the world. A combination D-sub with its ability to deliver both power and signal is finding its way into some of these new trends and these new applications. With a single connector being able to provide all those functions, it makes maintenance very straightforward. And so you'll find D-subs encroaching into some of these newer industries that you might think wouldn't be the place for a traditional connector like a D-sub. And taking those even further, there are several new trends within industry and within the commercial world that are seeing the need for a combined power and data connection in one go. The left-hand side there, we have industrial robots, and robots are very much a tool of the smart factory, of the latest generation of manufacturing environment. Here we have autonomous robots. The idea that these are devices that will trundle around in the factory environment, navigating their way from one place to another. But the same could be true of static robots. Static robots now no longer simply perform a task, they provide feedback to the smart factory operator that gives information about the condition of the robot itself, the speed and accuracy with which it's dealing with its task. And robots are now no longer dumb devices that simply act one part at a time. They are a combined feature of the smart factory, providing flexibility. And it requires data and signal to do that. And D-subs are a real solution for that. If we look at the commercial world, top right there, heat pumps have been in the news, certainly in the UK and I'm sure elsewhere. The idea that we can use a heat pump to gain energy from outside to heat our homes and our factories. And again, there is a data element to do with that. All of these systems require monitoring. So it's not just about finding a connector to provide power, it's providing a connector that delivers power and signal at the same time. The final picture there on the bottom right is an energy storage solution. We've talked many times about electric vehicles and about the lithium-ion batteries that are used to provide the energy for vehicles. But there is an increasing trend where these same lithium-ion batteries are used in static locations. If we have a factory or home that uses solar panels on the roof, or even a windmill in the backyard, collecting power for free from the environment around us, but those power sources don't work when the sun's not shining or when the wind's not blowing, and you need a way of storing energy for use later on. That's where the energy storage system comes in. It is a battery, but they are batteries that need monitoring. They are batteries that need their condition understood, and again, that's why a combined power and data connector is so useful. And then if we bring the technology right up to date and we talk about some of the latest trends in telecommunications. 5G is with us and 6G is on the horizon. People are looking at wireless communications using 6G technology, and the infrastructure that will be required to deliver that will be somewhat greater than some of the previous technologies. A cell for a 5G and a 6G transmitter is much smaller. It transmits over a smaller distance, and so we will need more infrastructure, and they require power as well as data. If we look the other way and look up into space, low Earth orbit satellites are now providing a lot of communication technology. Low Earth orbit is far closer to Earth than the standard communication satellites that we've seen over the years. Not only does that provide a much quicker response, lower latency, low Earth orbit is actually a little bit more protected from the radiation of space than the geostationary satellites that you find at 36,000 miles or whatever that is. It allows the designers of these low Earth orbit constellations, and we're talking about hundreds if not thousands of satellites, They can use commercial products because the products that are going into these satellites are somewhat protected from the harsh environment of space. And D subs have been used for many years in satellites and continue to be used for all the reasons we've talked about. They're shielded, they're compact, they're reliable. And so the combination D is being used in many, many different areas. And the very cutting edge of technology, everybody's talking about artificial intelligence and the power that's being delivered, that requires enormous data centers. And that's the picture at the bottom right there. Fantastic data centers being built around the world. And again, power and data all needed all at the same time. And that's where the D sub really provides that excellent service. And the combination D sub especially allowing a single connector to do all these things at the same time. We've talked a little bit about the D sub connectors and the combo D subs from the EDAC group. I just want to spend a couple of seconds to talk about the EDAC group and where these things fit in. The EDAC group of companies is 4 brand names with a range of different connector products. And here is just a snapshot of some of those products that we have. The D subs there at the top left in both the standard, high density, and also then the combination versions with the waterproof, with the standard, and we have accessories to go with. They simply form part of the connector families that we have. We have rack and panel connectors, we have inline connectors, we have board to board, board to wire, and various other solutions. So combo D subs from the EDAC group of companies are just part of the portfolio. And if you need any more information, we have a range of contacts. Here are some of your account managers across Europe. Feel free to have a look at these and contact them if you have any questions. Make contact with them, find out more. We can provide you lots more information. So just a quick note to Paul. Paul's been looking at the Q&A session. Do we have any questions that we need to answer? Not at the moment, I don't think. Okay. So I think for the moment then, it's best for me to say thank you very much for attending the second of our webinars. We will be hosting
Not another... at the moment, Dave, thank you.
Brilliant.
We'll
Lovely.
follow up afterwards with all the attendees and if there are any questions.
So I think for the moment, perfect. Then, lovely. Thank you very much, Paul. And thank you for watching. This has been the second of our Tech Tuesday. We will have another one on the first Tuesday of June. Please keep an eye on your inbox for the invite to that session. Thank you for watching. It's been great to have you with us, and we'll see you again next time.